Hey everyone, today we are diving into Apache Doris, a high performance database that's transforming analytics. When paired with AWS, it becomes an exceptional solution for real time, scalable, and cost effective data processing. Doris's lightning fast query engine, seamless real time data ingestion, and integration with BI tool perfectly complements AWS's elastic compute, storage, and global infrastructure. Together, they empower you to handle massive data workload effortlessly while keeping operations simple and efficient. Hello, my name is Juno, and let's explore how this incredible combination can supercharge your analytics game. So, what is Apache Doris? Apache Doris is a modern, high performance, massively parallel processing database for analytical workloads. It is designed for real time analytics and batch data processing. It is built to simplify data analysis and support various business intelligence scenarios. So you can imagine it as a tool that makes analyzing ton of data fast, easy, and fun. That's Apache Doris for you. One of the coolest things that Apache Doris is how it ensures your data is always safe and accessible. It stores both metadata and data in multiple replicas. And when you write data, it only needs the majority of these replicas to succeed. This means even if some node fail, the system keeps running smoothly. Doris also supports disaster recovery, whether in the same city or across regions. With dual cluster setup, if any nodes go down, it automatically isolates them to keep the rest of the cluster unaffected. Doris is incredibly user friendly because it's highly compatible with MySQL. It supports standard SQL syntax and many MySQL and Hive functions. This makes migrating your existing applications or integrating tool super easy. Plus, you can connect to Doris using MySQL client tools, making operations and maintenance a breeze. It even works seamlessly with the BI tools and data transfer tools, ensuring stable and efficient workflows. If you are someone looking for a real-time data warehouse, Doris has you covered. It can handle second level data ingestion, meaning it captures updates from the transactional databases and makes them available for analysis almost instantly. With its vectorized engine and advanced architecture, Doris delivers lightning fast queries in under a second. This makes it perfect for building a high performance, low latency platform. Doris can also function as a unified lakehouse, bridging the gap between data lakes and warehouse. It also smooths integration and free data flow between the two, so you get the best of both worlds. You can use warehouse capabilities to solve analytical problems in your lake while leveraging the data lake's management strength to maximize value. When it comes to data modeling, Doris gives you plenty of options. Whether you prefer wide table models, pre-aggregation model, or star snowflake schemas, Doris supports them all. You can flatten your data into wide tables using tools like Flink or Spark, or directly import it into Doris. From there, you can build views, materialize views, or even real time multi table joins to shape your data the way you need. Apache Doris is actually super compatible with MySQL protocol, which makes life easier for anyone familiar with MySQL. It fully supports standard SQL, so you can use your favorite clients tools or seamlessly integrate both Doris with BI tools for analysis and reporting. As for the architecture, Doris keeps things simple with just two main components, one being the front end or FE, which handles user requests, query parsing, and planning. It also manages metadata and keep tracks of the nodes in the system. Likewise, we have backend or BE, which takes care of data storage and executes query plans. It also stores data in shard with multiple replicas for reliability. This straightforward design makes it easy to understand and manage. In real world use, multiple FE nodes can be deployed to ensure disaster recovery and high availability. Each FE node has a full copy of metadata, and there are three roles in the FE setup. As you can see, the first one being master or leader, which handles metadata reads and writes. If there are changes, it syncs them to other nodes. Then comes followers, which reads metadata and can step in as the new master if needed. And lastly, observers, which focuses on reading metadata to boost query performance but doesn't take part in the leadership elections. Both FE and B components are horizontally scalable. You can add machines as needed, enabling Doris to support hundreds of servers and store tens of petabytes of data. Thanks to its consistency protocols, Doris ensures high availability and data reliability. Doris combines both computing and storage in a tightly integrated architecture. This design simplifies operations and significantly reduces the cost of managing a distributed system. It's built to handle large scale workload without the complexity of a separate compute and the storage layer. As discussed, Apache Doris has a super fast query engine based on massively parallel processing. This means it can split up tasks and execute them in parallel, both across nodes and within the individual nodes. For big complex queries, it distributes shuffle joins, making it much easier to handle large tables efficiently. Along with that, Doris is fully vectorized, which means it processes data in columnar format. What does this matter? Because it reduces unnecessary function calls, boosts cache efficiency, and takes full advantage of modern CPU features like SMID instruction. The results? Doris can perform 5 to 10 times faster than the non-vectorized engines, especially working with the wide table aggregations. Doris uses adaptive query execution, which is basically its way of thinking on its feet. It adjusts the execution plan in real time based on what's happening during the query. For example, it can create a runtime filter and push it to the lowest level of scan nodes to reduce the amount of data processed. This means join becomes more efficient. Dory supports filters like in, min, max, and bloom filters, making it super flexible for the complex filtering tasks. Doris combines two optimization approaches. One is rule based optimization, which handles things like constant folding, rewriting subqueries, and pushing down predicates to move efficiently. It also combines cost based optimization, which focuses on join reordering and is constantly being improved for better statistic collection and cost modeling. These optimization make Doris great at balancing speed and resource efficiency, no matter how complex the query be. So let's just understand how Apache Doris actually functions well with AWS by implementing a project. As you already know, Apache Doris is highly efficient and highly performant, and along pairing it with AWS, who actually shares the same concept of cost, scalability, and performance, it makes it a exceptional solution for data analysis. So let's just try to create a project around combining both of these uh, functionalities using Apache Doris on an AWS environment. So here you can see this is a simple flow of what we are trying to implement. So this is a basic project where we will be focusing on implementing Doris on AWS. So the data is ingested in the real time via AWS Kinesis or in batch via AWS S3. Further, the data would be processed by AWS Lambda function, and we would perform some further transformation if needed using this AWS Lambda function. Once it's done, it Lambda function would ingest this data in Apache Doris for storage and querying. Once the data is loaded into Doris, it can be queried in real time, offering fast OLAP style querying for the large data set. For the data visualization, we would use AWS QuickSight to fetch the data from Doris and generate interactive dashboards, displaying key metrics or trends from the data. We'll also implement some type of monitoring, and we have Amazon CloudWatch to do it. This will allow continuously monitoring the system performance and send alert if there are any issues with EC2 instance or Apache Doris. Sounds fun? So let's try to implement this solution in the upcoming videos. So I'll meet you there. So that's it for today and have a nice day.